Hello students, today we are going to see some more interesting and important questions from MS Chouhan sir's Organic Chemistry Isomerism Level 1 and the question from 141 to 150. Come on, let us discuss, and these 10 questions are related to geometrical isomerism and how to identify the geometrical isomerism from these options. That is a main idea. Come on, let us discuss the first question. Which of the following compounds will not show geometrical isomerism across the pi bond? Right, so usually how to identify the geometrical isomerism? Very easily, geometrical isomerism, it will be possible only in alkene when we are talking about pi bonds, right? Alkene only it is possible. Right, now in that, another one more idea I just bring for you. See, now for example, C double bond C. Now here compound A and compound B, and this side compound A and compound B. Now this is possible to show geometrical isomerism. Why? Both are different groups or atoms attached to that adjacent carbon with a pi bond, so this can show geometrical isomerism. So they are asking will not show geometrical isomerism. Come on, let us check. So here C double bond C only it is available. Okay, now in that methyl group, both are same group, but it is cycloalkane, right? So cycloalkane means CH2 in that one hydrogen which is replaced by methyl, the other hydrogen will be there, so both are wedge position, so that means another one it will be dash position, so dash position hydrogen. Okay, now easily we can identify RS configuration. How to identify RS configuration? Fourth priority should be on dash, then clockwise means R, anti-clockwise means yes. Okay, so in that way speaking, here 1, and this side it is 2, and this side it is 3, and this side it is 4. So 1, 2, 3, and 4, that means this is clockwise. So clockwise means it is R, right? And the same way here also, right? 1, and this side it is 2, and this is 3, and this is 4. So that means this is what it is, anti-clockwise. So anti-clockwise means yes. Okay, so fourth priority should be on dash, clockwise means or, anti-clockwise means yes, according to CIP rule, you know very well. Okay, now let us check whether GI it is possible in this compound. Okay, in that, here C double bond C, one side H, the other side CH3. Okay, different groups or atoms attached. In this side also different groups or atoms attached, so two chiral carbon it is available. That means two chiral center it is available. Okay, now in that, which is higher, which is lower, so this is R means of course this CH3 it is first one, and hydrogen it is second one. Okay, now another one more point I wanted to mention here, how to identify which is greater and which is smaller. According to CIP rule, R it's greater than yes, right? Okay, so R it will come 1, and yes it will come 2. So 1 and across 1, here 2 across 2. So geometrical isomerism 100% possible. So option A, geometrical isomerism is possible. So geometrical isomerism is there. Now option B, now they are asking will not show geometrical isomerism across pi bond, right? Okay, now this is wedge position chlorine, and opposite side dash position chlorine. Just here what is it? Double bond it is available, and the same way wedge position bromine, dash position bromine. Now in that point we can identify very easily RS configuration. Okay, now wedge position chlorine means dash position what will be there? Dash position hydrogen will be there because CH2, right? So that means which is 1, 2, 3, 4. Can we identify in that way? So 1, 2, 3, 4, what it is? Here where you will get 1, chlorine only will get 1. Why? Because it is atomic number higher. And the second one, what it is? Of course, this is this carbon which is attached to the double bond. And this CH3, this is third one, and this is fourth priority should be on dash position. So that means what it is? It's a clockwise or anti-clockwise. So 1, 2, 3, and 4, right? So that means clockwise dash position is there on what it is, sorry, dash position is there, have fourth priority is there on dash position. So 1, 2, 3, 4 clockwise, so that means this is R. I hope you got the clarity. And the same way another one, what it is here, Cl is available. Now hydrogen it will be fixed over here. So hydrogen when comes over here means this is wedge position will be there on hydrogen. Actually hydrogen is the lowest priority, it has to be there on dash position only. So that means here according to the higher atomic number, so this is 1, and this is 2, and this is 3, and this is 4, right? So that means here what it is, fourth priority should be on dash. So interchange will be taking place. So interchange is taking place means one it will come this side, four it will go that side. So that means what it is? This is actually what it is? Anti-clockwise. So anti-clockwise what it is? Yes. But here what it is? This is actually 1, 2, 3, 4. So this is anti-clockwise. But due to that exchange of wedge and dash, yes, it will go out and R will be there. So both are R and R. Right. Now both are R and R. The same way this also R, wedge side, dash side. So here also you can identify the same. So same, it is R means it cannot show geometrical isomerism. So option B will not show geometrical isomerism. So which is the correct option? B. But still there are two more options are available. Let us check. So C and D. Now in that which is these both which is showing geometrical isomerism, which will not show geometrical isomerism, let us check. Now in that way here also the same. Here dash position hydrogen, dash position hydrogen. Why I just put it dash position hydrogen hydrogen? Because wedge position chlorine, here also wedge position chlorine. So that means this is 1 and this is what it is 2. This side it will be 2, right? Because carbon which is connected with double bond. And this is 3 and of course this is 4. Fourth priority is there on dash. So that means 1 2 1 2 3 4. So that means this is clockwise. So clockwise means R, right? And the same way now this is 1 and this is 2 and this is 3 and this is 4. So very easily born with silver spoon, like it is coming clearly. So anti-clockwise. So dash position on that what it is, fourth priority is there on dash position. Anti-clockwise means yes, right? R and yes. And the same way this also, this side wedge it is there, no? So dash position hydrogen will be there and this side also hydrogen will be there. Okay, so in the same way here what it is, bromine will give that first priority 1 2 3 and this is for hydrogen, it is 4, right? This is 4. So what it is, you will get it here 1 2 3 4 anti-clockwise. So anti-clockwise means what it is? Yes, right? And the same way here I'll change the color so that it will come to easily. Now this is for the priority is there on dash position, right? Okay, this is 1 and this is 2 and this is 3 and this is 4. Okay, that means 1 2 3 4 1 2 3 4. What it is? Clockwise. So clockwise means what it is? R. So this is yes and this is R. And the same way this is R and this is yes. Just to the opposite, right? Both are. So that means definitely this also can show geometrical isomerism. Hope you got the clarity how to identify that R is configuration. Indirectly we are seeing that geometrical isomerism also, right? Okay, now the last one. Here the same wedge position and dash position. Here fluorine instead of chlorine, here fluorine is available, that's all. So and the same way you will get what it is, R yes configuration. Why? Because both are similar, only what it is, instead of chlorine here fluorine it is available, that's all. So R is configuration. And the same way here also wedge position iodine. So iodine same ditto, only thing halogen it is changing, right? So here also what it is, yes and R, right? So yes R, RS, yes R. So that means here also can show geometrical isomerism. Okay, now in the question they are asking which does not show geometrical isomerism. Okay, that means which cannot show geometrical isomerism. Option B cannot show geometrical isomerism. That is the correct option. This cannot show geometrical isomerism. See, both are similar, R. So R means it will not show geometrical isomerism. Whereas here these three options are can show geometrical isomerism. Hope you got the clarity how to identify the geometrical isomerism and which is not possible for geometrical isomerism in this question. Come on, let's go to the next question. Here they have given this kind of compound. Choose the correct relation between L1 and L2, right? Okay, now here two double bonds are there. That means even cumulene, right? Even cumulene. Allene also we can say cumulene, right? Okay, now in that even cumulene do not show geometrical isomerism, right? Do not show geometrical isomerism. That is very, very important to note down. Even cumulene. So that means two double bonds are there. It does not show geometrical isomerism. Three double bonds are available. That means 100% it can show geometrical isomerism. This is a fundamental basic concept, right? Okay. Now in this point, L1 and L2, correct relation between L1 and L2. L1 is equal to L2. L1 it's greater than L2. L1 it is lesser than L2. L2 is equivalent to 2L1, right? Okay, now distance between this hydrogen and this hydrogen, that means this is wedge position and this is dash position. This is above the plane and this is below the plane. Now this L2 from here to here and then here. So that means this does not show geometrical isomerism. First and foremost, even cumulin does not show geometrical isomerism because it is two double bonds are available. And one more idea, I just bring it to you. Planar molecule can show geometrical isomerism. How do we identify planar molecule? Now, for example, C, double bond C. Now, in this CH3, it is there. In this hydrogen, it is there. And the same way here, CH, it is there. CH3, it is there. And here, hydrogen, it is there. Okay, now, first and foremost, I would like to mention this can show geometrical isomerism. Why? Because you see here, C, double bond C, here CH3, and here CH3. Right now, here hydrogen and here hydrogen. Okay, so that means the position, the relation between L1. So that means from here to here, L1, from here to here, L1, and from here to here. Now, if this is no, this is from here to here, L2, right? So L1, which is what is that relation between L1 and L2? First and foremost, this can show geometrical isomerism. Yes, it is possible. And L1, it is smaller than L2. L1, it is smaller than L2. That means L1 and L2, which is not equal. So these both are not equal because it can show geometrical isomerism, right? And one more thing, it's an odd cumulin. So odd cumulin, 100% it can show geometrical isomerism. And one more thing, it's a planar molecule. It's a planar molecule. Planar molecules can show geometrical isomerism, right? Okay, now this even cumulin do not show geometrical isomerism, and it is not a proper planar molecule, right? Now L1 is equivalent to L2. So generally speaking, what is the main point over here? Relation between L1 and L2. Here actually what it is. So L1, it is equivalent to L2 because it does not show geometrical isomerism. So which is the correct option? Option A is the correct option. Okay, now the next question, I just bring it here only because both are like similar kind of question. So only very few points will be vary. So to identify, I just bring it another question also here only. Right now here what it is, how many double bonds are there? 3 double bonds are there. That means odd cumulin, right? Odd cumulin can show geometrical isomerism. So odd cumulin can show geometrical isomerism means this is a planar molecule. Planar molecule. First and foremost, this is a planar molecule, right? Okay, now choose the correct relation between L1 and L2. The same question but different. Sorry, same concept, different question. Right now, the same idea we just apply over here. So this L1 and this L2, actually, it will not be equal at all. Why? Because it is a planar molecule. So L1, which is not equal to L2. So that means which will be more higher length means here higher stronger, that means greater than means here actually L2 which will be more, that means more greater than L1. L1 it is the length, it will be smaller, and L2 it is bigger, right? So L2 it's greater than L1, right? Okay, hope you got the clarity. Right now that means which is the correct option over here. The same idea I just bring it over here also the same way. C double bond C double bond C double bond C, right? So that means here odd cumulin in that hydrogen, here CH3, and the same way in that yeah, I just put it this side, here hydrogen, here CH3, and this side CH3. Now you see the length between this hydrogen and this hydrogen, this is L2. Now another one I just bring it here, C double bond C double bond C double bond C. How many? 1 2 3, right? Now here CH3, here hydrogen, here CH3, and here hydrogen. So that means this is L1. Both actually it is same size, no, I mean cis. Okay, cis and trans in that way. So this is L1 and this is L2. So that means which is longer? That means L2 it is greater than L1. So L2 it's greater than L1. Where it is L2 it's greater than L1. Okay, now here in this point, yeah, L1 it is lesser than L2. So that means just I just bring it opposite side. So L2 it's greater than L1. L1 it is lesser than L2. So option C is the correct option. So which is the correct option? Option C. First and foremost, suppose if it is coming like this means we have to identify whether it is an odd cumulin or even cumulin. Odd cumulin can show geometrical isomerism. Even cumulin do not show geometrical isomerism. And one more thing, planar molecule, whether it is possible or not, we have to check it. Then we have to identify very clearly even cumulin comes means it is L1 is equivalent to L2, whereas odd commelin comes means L2 it is greater than L1. Okay, fine. In this question, we are talking mainly about even commelin, odd commelin. Even commelin do not show geometrical isomerism, whereas odd commelin can show geometrical isomerism. You know the main reason? Even commelin, because of the terminal carbons are perpendicular to the planes, whereas odd commelins double bonds allow the terminal group remain in the same. So that is the main point. So terminal carbons are perpendicular to the plane, whereas odd commelin, actually it is what it is, double bonds allow the terminal groups remains the same. I hope you got the clarity. Okay, come on, let's go to the next question. Isomers are possible for the above compound. Right now here, as we check here, actually two chiral carbon it is available. So how many chiral carbon? Two chiral carbon it is available. So how do we identify two chiral carbon? See, this is cycloalkane, so CH2 in each corner, right? So that means here CH2, one hydrogen which is replaced by CH3, another hydrogen it is still pending. So both the side hydrogen, so you are having what it is, four group, that means four different groups or atoms attached to that carbon. So that means it is two chiral carbon it is available. So two chiral carbon is there, no? So we can bring it that idea about cis and trans isomer. So how do we bring cis and trans? Both the side wedge, right? So that means here both the side wedge means here CH3 and here CH3, right? And another one part here, what it is? Here one side it is wedge, the other side it is dash. So that means this side it's wedge and this side it's dash. Any side, right? Right. So this is a dash. So that means CH3 and then CH3. So as I mentioned here, this is a cis and this is a trans. Right. So cis and trans position. So that means how many GI it is possible. This is actually 2 GI it's possible. Right. So 2 GI it's possible. And one more point I wanted to mention here, geometrical isomers, when we are talking about, I just bring that idea about stereo, that is diastereomers also. So geometrical isomers are specific type of diastereomers. Diastereomers differ in the specific rotation arrangement due to restricted rotation. Now, another main point, all geometrical isomers are diastereomers. Listen, all geometrical isomers are diastereomers because they are not mirror images, but not all diastereomers are geometrical isomers. So geometrical isomers, already I just mentioned this statement in the first starting of the video only. Right now I repeat it, all geometrical isomers are diastereomers because they are not mirror images, but not all diastereomers are geometrical isomers. So diastereomers, it cannot be possible for geometrical isomers, but all the geometrical isomers are diastereomers. Hope you got the clarity about this question. Come on, let's go to the next question. The next question also same idea, but a different question. Right now here CH3, here C2H5. This is methyl group, this is ethyl group. Even though methyl group, ethyl group, this also the same idea only is. Here also hydrogen, it is there, here also hydrogen. So how many geometrical isomers are possible for the above compound? See, easily you can identify how many it is possible. The same idea I just bring it here also. One it is wedge side, the other one it is dash position. So that means this side it is wedge and this side also it will be wedge only. And same idea only, the other side, this side it is wedge and this side it is dash. So dash position here C2H5 and here CH3. Right, that here C2H5 and this is CH3. Right, so this means what it is, cis and trans only. So this also what it is, cis and trans. So this is cis and this is trans, like methyl, ethyl. So this is trans. So that means this also, how many geometrical isomers are possible? So this also can show two only, right? Now the next question, you see here CH3 group it is there, here also CH3 group it is there. So that means CH3 just to the opposite CH3. So one it is wedge, okay, now the other one it is dash. So here now you see here the same idea I just bring it. All these points are number of ideas, no, same kind of concept but different questions. The same way here also. So one side it is wedge, the other side it will be dash. So this is wedge and this is dash. So that means this is cis and this is trans. So this also, yeah, what it is, two isomers, or that means two geometrical isomers are possible. I hope you got the clear idea about these kind of questions. Okay, now next one more question. Here same kind of methyl, ethyl, like that easily we identify, but here methyl group it is there, bromine it is there. Now in that way, how many geometrical isomers are possible? So that means this also you can identify. Here also two only, cis and trans. Here cis and this is also cis. So here what it is? CH3 and here Br. And the same way opposite side. See, two chiral center it is there. So in that way you can identify this is CH3 and this is dash position Br. Okay, hope you got the clarity. Now you can change that wedge and dash in a different way also, no problem. But how many geometrical isomers are there? That is two only. That is what I just mentioned. That is cis and trans. Spatial arrangement, not mirror images. So geometrical isomers are equivalent to that diastereomers. Diastereomers also the same spatial arrangements, different spatial arrangement. But not all the diastereomers will be geometrical isomers. But all the geometrical isomers can be the diastereomers. Right? I hope you got the clarity of all these questions. Come on, let's go to the next question. Idea in the same concept. As you observe this, how many geometrical isomers are possible for the above compound? See, as I mentioned, minimum 2 chiral carbon should be available to find the geometrical isomers. Do you think there is a 2 chiral carbon? See, here 1 CH3, here 2 CH3. So that means this is another one more point. Here actually what it is, C double bond C, even whether it is single bond or double bond, here actually what it is, A and here B. And the same way here also A and it has to be B. So different groups or atoms attach that chiral carbon. So first and foremost, here chiral carbon and here two groups or same groups which is attached to this carbon. So that means there is actually no geometrical isomers only available. So how many geometrical isomers are available? Zero. I hope you got the clarity. How to identify geometrical isomers? Minimum 2 chiral carbon. Then only geometrical isomers it is possible. Right. I hope you got the clarity. Why? How zero geometrical isomers are possible in this compound? Because two are same groups. It has to be a different group. Then only you can identify that geometrical isomers. But here, same groups, right? Okay, right. Come on, let's go to the next question. Next question will give better idea. Yes, here another one more question. 149th question. 149th question, right? So here in this CH3, 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 that is 246, like, or 135. This is actually what it is, trimethyl 135 trimethyl cyclohexane. So how many geometrical isomers are possible? So in this also cis and trans we can bring it. How do we bring it cis and trans? See, in that 135 all become wedge. So this is wedge and this is wedge. Right now this side, right? So this side it's wedge and this side it's wedge. So both the side, I just put it upside down. And the other one, what it is, the same question actually we have seen in our third video or fourth video, because that questions also which is related to geometrical isomerism only. So here one side it is dash, the other two sides it will be wedge. I just put it upside down. Okay, so that means everywhere CH3. That is what they mentioned. No, CH3 and here CH3. Both the side, I just put it like this way. So you can put it directly also. CH3, CH3, and CH3 position you can find everywhere cis. See here cis, and here also cis only you can identify. But whereas here wedge position, here dash position, so you can find trans, right? Trans, right? And here also trans, right? So cis and trans, only two isomers, that means two geometrical isomers are possible. I hope you got the clarity completely about this question. Now the last question, let us check. Now the last question we are talking about what it is, the same even cumulin, odd cumulin. So even cumulin, how many? One, two, three. Three double bonds are there. That means this is odd, right? Odd cumulin. Odd cumulin can show geometrical isomers. It is possible. Now they are asking first and second geometrical isomers or each other, because so these geometrical isomers of each other, because it is L1 is equivalent to L2, L1 is greater than L2, or L2 is greater than L1, and L1 and L2 cannot be compared. See, the same idea what we have gone through, that 42 and 43, the same question which is repeated in a different way. So here there also I just mentioned this is odd cumulin can show geometrical isomerism. So in that way, here CH3 and here CH3L1, and this CH3 and this CH3L2 will be greater than L1, because what it is, mainly it is a planar molecule. So the other one, it is what it is, odd cumulin can show geometrical isomerism. And what it is, mainly topic, especially even cumulin do not show geometrical isomerism due to terminal carbon or perpendicular to the plane, whereas odd cumulin can show geometrical isomerism, and it is double bonds allow the terminal group to that it remains the same, right? So this is the main idea. So here L1 and L2, so L1 it is actually smaller, this is very smaller than this is L2, from here to here diagonal it is larger, okay? So L2 it's greater than L1. So L2 it's greater than option C is the correct option. I hope you got the complete idea about these questions. Now in our next video we are talking about another 10 more questions, and thank you for watching.